Welcome back to the deep dive. Today, we are undertaking what might be our most critical mission yet.
I think you're right.
We're charting a course through the single most influential, most expensive, and maybe, just maybe, the most misunderstood force shaping our entire global economy right now. I'm talking about artificial intelligence.
That's absolutely right. And our source material today is really designed to cut directly through all that noise, all the hype.
There's so much of it.
So much. We aren't just looking at the dizzying valuations. We are going to contrast the financial projections with the fundamental technical realities of today's AI systems. We've got these high-stakes macroeconomic and investment forecasts from Goldman Sachs looking all the way out to 2026.
And we're holding those up against the fierce technical critique of current generative AI from experts like, say, Gary Marcus.
Exactly.
And the ultimate goal of this deep dive is, well, it's to figure out the pathway out of all this uncertainty. I mean, if the market is betting trillions of dollars on AI, and that's a bet so large it just dwarfs the economic output of entire nations, it's staggering.
We need to know if the underlying technology can actually deliver the kind of transformative returns that are being promised. And to do that, we'll be exploring a foundational engineering approach proposed by Dr-Eng-Prof Yogesh Malhotra, really focusing on how to engineer outcomes and maximize ROI by moving far beyond today's backward-looking large language models.
And that's the mission, isn't it? It's to analyze a volatile, high-stakes investment environment where historical bubbles are a major, and I should say an acknowledged risk,
Right.
and contrast that reality with the actual scientific and engineering paradigm required for resilient, sustainable breakthrough intelligence. We're trying to move from market speculation, which is, inherently risky, to technical blueprints, which actually promise engineered success. Okay, so before we get into those technical limitations, we really need to understand the astonishing financial landscape that created all this hype in the first place. What exactly are the Goldman Sachs economists betting on? Let's unpack this, starting with that macro picture that frames this massive wave of AI investment.
The GS reports, they really paint a complex picture for the period leading into 2026. The backdrop isn't one of, massive boom or bust. It's more of a cautious return to pre-pandemic economic norms. And it's all heavily influenced by central bank actions and, of course, geopolitical friction.
Okay, specifically, let's focus on the U.S. labor market. There was that prolonged tightness post-COVID, but the GS analysis, it pointed to that easing up pretty dramatically, right?
Correct. The analyst noted that the post-pandemic labor market tightness was only expected to ease back to pre-pandemic levels in early 2024. And this easing is a crucial indicator.
Why is it so crucial?
Well, it suggests that wage pressures may stabilize. And that allows inflation to remain anchored without requiring more aggressive tightening from the Federal Reserve. This stability, it creates the precise environment where investment in productivity-enhancing technologies like AI becomes highly, highly appealing.
And this stability then leads to the forecast for future monetary policy. So we're talking about, what, potentially more rate cuts?
Precisely. If that labor market weakness persists, and, it could even be accelerated by the initial adoption of labor-saving GenAI tools in some sectors.
Or even federal layoffs.
Right, or broader federal layoffs.
Right.
Goldman Sachs forecasts the potential for 2 further rate cuts in 2026. And this scenario is really crucial. It supports a soft landing narrative, it pushes the policy rate lower, and it keeps capital costs manageable for the huge investments we're about to get into.
That sounds broadly optimistic for the domestic U.S. economy. I mean, especially since they had lowered U.S. recession odds to just 25%. They factored in risks being removed, like the debt limit tail risk being resolved, and expected only, modest GDP drags from tighter bank lending. But you mentioned geopolitical friction. That optimism for the U.S. domestic market has a pretty significant asterisk when we look globally.
Oh, absolutely. The global trade environment is the major downside risk mentioned across all the GS reports. And we are not just talking about minor trade disputes here. The U.S. effective tariff rate currently sits at 18%.
18%.
And to put that in historical context for you, that is the highest average tariff rate consumers have faced since 1934.
Since 1934, that's just astonishing. I had no idea the global trade environment was that hostile, especially considering all the optimism about the domestic U.S. economy.
It creates a tremendous tension. I mean, sure, companies, particularly large multinational tech firms, they've adopted sophisticated strategies.
Moving manufacturing, re-engineering supply chains.
Exactly, and selectively passing on costs to protect their margins. But the sheer magnitude of that tariff rate, it presents a continuous threat. The risk is that if the cost pass-through accelerates, it's going to act as a major headwind to growth in 2026.
Which would force consumers to absorb higher costs and potentially dampen those projected productivity gains from AI.
That's the fear.
So we have this environment, stable domestic finance, easing interest rates, but a hostile global trade backdrop. And into this complex gap steps AI, promising to be the great productivity equalizer. Let's move to those productivity numbers. What are the hard estimates GS economists are attaching to this transformative potential?
The transformative potential is, well, it is indeed massive. And it's not purely theoretical. We're already seeing early results. The best data point cited is developer productivity. In areas like coding assistance and bug fixing, studies are observing productivity boosts in the range of 15 to 20% by using these new generative AI tools.
A 15 to 20% jump in efficiency for knowledge workers that's huge. But what happens when you extrapolate that, widespread adoption across the entire U.S. economy?
That's where the trillion-dollar forecasts come from. GS economists estimate that widespread AI adoption rolled out over a 10-year period could boost annual U.S. labor productivity growth by a really substantial 1.5 percentage points.
Okay, let's pause on that figure. 1.5 percentage points. It sounds like a dry number, but it's critical. What does a 1.5 percentage point rise in productivity actually mean for the average person listening? Not just for corporate balance sheets.
It fundamentally changes the economic game board. Historically, productivity growth is the engine of sustained wage growth without inflation.
Right.
A sustained 1.5 percentage point boost means the economy can grow faster, it can absorb greater demand, and it can allow for higher real wages without triggering an inflationary spiral. It's what could lift the speed limit on the U.S. economy, allowing it to sustainably grow trend real GDP by 1.1 percentage points for a full decade.
The difference between sluggish growth and a dynamic, expanding economy.
That's it, exactly.
And then feeding that into the equities market, the financial impact becomes just staggering.
It does. Based purely on this productivity surge, GS estimates it could lift the S&P 500 fair value by 9% compared to current levels. And this is reflected in long-term earnings forecasts as well, where the S&P 500 earnings per share in 20 years could be 11% greater than current baseline assumptions.
9% upside just from the productivity gains, but the sources are also quick to highlight the massive uncertainty attached to those figures.
And that's a critical caveat. The potential productivity boost range is incredibly wide. It spans from a modest 2.3 percentage points up to a massive 3.0 percentage points annually.
Wow.
This wide range really demonstrates the lack of certainty in the modeling. And consequently, the S&P 500 upside range is also vast. It stretches from a 5% bump to a 14% massive gain.
And that uncertainty, that gap between 5 and 14% upside, is the perfect foundation for a market bubble because all the optimism is currently driving this unprecedented capital deployment.
Indeed. We are seeing a capital expenditure, or CapEx, arms race, the estimates for CapEx growth among the hyperscalers.
So that's Amazon, Google, Meta, Microsoft, Oracle.
Right. The estimates for them have been consistently, sometimes wildly, underestimated by analysts every single quarter for the past 2 years.
Can you give a concrete example of that underestimation? Just how far off are they?
Certainly. One example cited showed that for 2025, consensus CapEx growth was initially estimated at 22%.
Okay.
The actual realized growth ended up being 64%. This pattern of consistent underestimation, it signals a corporate belief system that just says, we must spend more and we must spend faster than anyone is anticipating.
And the spending is highly concentrated, which is, I think, where the structural risk truly lies.
The concentration is extreme. A remarkable 27% of the entire S&P 500 capital expenditure comes from just 5 of these hyperscalers.
Just 5 companies.
Just 5. And to illustrate the scale of this concentration, those top 5 UF tech firms collectively hold a staggering value of $17.6 trillion.
Wait, hold on. $17.6 trillion. That number is so abstract. What does that compare to, say, on a global scale?
It's a stunning comparison. $17.6 trillion exceeds the combined annual GDP of Japan, India, the UK, France, and Italy.
No way.
Yes. Their combined GDP is approximately $17.1 trillion. So you have 5 companies valued higher than the economic output of 5 major industrialized nations combined. That level of dominance and concentration risk is, well, it's historically unique.
So the sources then raise the natural question. Does this enormous investment, concentrated in so few hands, driven by the promise of historic productivity gains, Does it look like a bubble?
It certainly shares behavioral similarities with prior innovation booms, the adoption of electricity in the late 19th century or the PC and internet boom of the late 1990s.
Both of which ended in bubbles and busts.
Exactly. Both of those eras were characterized by massive capital deployment based on futuristic visions, and both ultimately ended in bubbles and subsequent busts.
But the sources also noted some key differences from the infamous dot-com crash of 2000, which suggests it's not just a simple repeat.
That's vital context. Today's market is arguably more fundamentally sound than it was in 2000. Valuations, while high, are lower than the 2000 peak. More importantly, the largest companies, these hyperscalers, have vastly stronger balance sheets. They generate massive free cash flow, and they often operate profitable core businesses that underpin their speculative AI bets.
Okay.
However, despite these structural improvements, the behavioral similarities, they remain highly concerning.
Hold on. If Goldman Sachs believes the large companies have stronger balance sheets than during the 2000 bubble, why is the bubble comparison still so valid? Where's the structural weakness that validates this extreme skepticism?
The weakness lies in the justification for the AI capex. Specifically, the forecasted multi-trillion-dollar data center build-out by 2030, which NVIDIA's CEO projected could hit $3 to $4 trillion.
An incredible number.
And as David Kahn from Sequoia Capital argues, the only way to financially justify that unprecedented spend is the attainment of artificial general intelligence. Absent AGI, the capex is currently a bubble driven purely by speculation.
So this sounds like the structural risk isn't the balance sheet of these companies, but the revenue pipeline.
Exactly. And Gary Marcus reinforces this, stating AI is certainly in a financial bubble, because these lofty valuations are currently detached from actual, sustained, proven profitability generated by AI customers. He points to the ecosystem's dangerous circularity.
Tell us more about this concept of circularity. It sounds like a deep structural vulnerability in this whole AI infrastructure boom.
Circularity implies that the spending is primarily propping up the supply chain, rather than being fueled by established, profitable customer revenue at the top of the stack.
Okay, so in a healthy supply chain, a dollar flows from the end user customer down, right? And that creates profits for the infrastructure providers.
Correct. But in the current AI ecosystem, critics observe a scenario where if a dollar comes in at the top, NVIDIA keeps $1.20.
That's a very sharp way to put it.
It illustrates that the supply chain is feeding itself. Demand is driven by massive infrastructure investment in chips and data centers, based on the hope of future AGI-driven profits, not present revenue. Marcus calls this the Wile E. Coyote moment.
Ah, I like that.
They've sprinted off the cliff, they've invested trillions in the air, and they haven't looked down yet to see if the ground, the established necessary profit streams, is actually underneath them. The entire financial thesis hinges on the underlying technology achieving something it is yet to prove capable of.
And here's where it gets really interesting. If the financial system is pouring trillions into AI based on the hope of future AGI-driven profits, we have to ask if the underlying technology, generative AI and LLMs, can truly deliver on that promise. Is that Wile E. Coyote moment approaching?
For many technical experts, the answer is a resounding no, at least not in the current form of generative AI. The massive investment is chasing a paradigm that is already showing fundamental structural limits.
We have a very potent and highly influential critique from Gary Marcus, Professor Emeritus of Psychology and Neuroscience at NYU, and he cuts right to the core flaw of today's most celebrated AI systems. So what is that fundamental critique?
Marcus argues that generative AI, specifically these LLMs, is fundamentally flawed because it is, and I quote, essentially autocomplete on steroids.
That's not just an insult, is it?
No, it's a precise technical description of their function. The core mechanism is trained merely to predict the next token, the next word or piece of code, in a sequence based on vast statistical analysis of the data it was trained on.
So they're incredible pattern matchers, but they lack any true comprehension.
Exactly. They are reflexive statistical machines. They're excellent at probabilistic approximation, but they are not fundamentally deliberative reasoning machines. They learn the statistics of how words are typically connected in large, corpora, but they are not learning the underlying abstract concepts, not causation, not meaning.
Which means they lack the human ability to build an internal model of the world, a sort of common sense foundation.
Precisely. Marcus emphasizes that unlike human beings, who inherently know that objects don't pass through walls or that fire burns or that cause precedes effect, AI systems today have no genuine compositional internal model of the world around them.
Can you give us a tangible example of how this lack of an internal model shows up as a flaw?
A classic example is counterfactual reasoning or compositional complexity. If you ask a human child, if you put a square block on a round block, what will happen? They can immediately visualize the instability.
Right, because they have an internal model of physics and shape.
Exactly. An LLM, lacking that model, has to rely purely on having seen similar sentences or images in its training data. If it hasn't seen that specific scenario, it hallucinates. It generates a statistically plausible but physically impossible response. This fundamental lack of an internal model is why issues like hallucinations and the inability to internally fact-check their own output persist. It leads to low reliability. You just can't trust a system built for approximation to deliver truth.
And this issue is critical because the industry had placed immense financial and intellectual faith in what were called scaling laws.
Oh, absolutely. The industry mantra for years was bigger models would always yield better results. The scaling laws predicted that by simply throwing more data, more compute, and more parameters at a neural network, performance would improve proportionally, and that would inevitably lead us to AGI.
And Marcus cautioned against this faith.
He did, and now we are seeing the consensus weaken.
How is that faith weakening? What are the signs of these diminishing returns?
Well, the disappointments surrounding recent large model releases show that incremental scaling has not solved the core problem of reliability. You might get a marginal performance boost, but the fundamental flaws, the hallucinations, the compositional failures, they all remain. The phrase diminishing returns has now entered the mainstream discourse, which signals that merely scaling up existing network architectures will not solve the core problems of genuine intelligence and trustworthiness that are required to justify the massive capex we talked about.
That's a huge turning point. It suggests the current technical approach is fundamentally stalled. This is what Marcus calls being stuck in the age of alchemy.
It's a powerful analogy. In the age of alchemy, practitioners could observe phenomena. They could get something to happen, but they lacked the foundational theoretical understanding of chemistry to reliably and sustainably engineer outcomes.
And today's generative AI is similar.
Very similar. We know we can generate quality content, but we lack the foundational theory of how to build true, reliable, compositional intelligence into machines. And this failure, it requires a paradigm shift, one that moves beyond the statistical architecture of what's called software 2.0.
Okay, so let's briefly review that software 1.0 to 2.0 shift to frame this next required step.
Right. So software 1.0 was the traditional deterministic method. Human programmers writing explicit function-by-function code for every single task. It was reliable, but brittle.
And software 2.0.
Software 2.0, ushered in by machine learning, shifted the work away from writing explicit code to collecting massive amounts of training data for a neural network to learn patterns from. And while it was revolutionary, the issue with traditional ML is that the development cycle, label data collection, error correction, fine-tuning, it's incredibly labor-intensive and expensive. And that limits its deployment and its reliability in real-world dynamic environments.
So if scaling software 2.0 is hitting diminishing returns, what technical path is quietly emerging to bridge that gap toward AGI to move away from this pure statistics model?
The industry, often very quietly, is beginning to recognize the limits of the purely neural network-only approach. Marcus notes a subtle but critical shift toward what is called neurosymbolic AI. This approach is crucial because it seeks to combine the strengths of both paradigms.
Okay, can you elaborate on what neurosymbolic AI actually does? How does it combine statistical learning with symbolic representation?
Think of it this way. The neural network layer, the neural part or software 2.0, is excellent at pattern recognition and approximation. It sees that a million photos of dogs share certain pixel patterns.
Right.
The symbolic layer, the symbolic part, or software 1.0 concepts gives the machine explicit rules and representations of the world. The concept that a dog is a mammal or gravity makes things fall.
So it's combining the best of both worlds.
Exactly. Neurosymbolic AI embeds those symbolic tools, like code interpreters or knowledge graphs, directly within the LLMs. The best real-world success story cited is DeepMind's AlphaFold. AlphaFold predicts complex protein structures not by purely statistically guessing the next amino acid sequence, but by combining neural networks with structured symbolic tools based on known biochemical physics. This allows models to move beyond mere pattern recognition and engage in structured, deliberate, and representational reasoning about the real world, which is necessary for complex problem solving.
And this realization that these current approximation machines are fundamentally limited is precisely what has been slowed down by the dynamics of capitalism, according to the sources.
That's the crux of the intellectual challenge we face. The dynamics of capitalism incentivize focusing on technologies that are, well, relatively easy to build and monetize. LLMs are easy to monetize because they can generate content cheaply and immediately.
And that's created an intellectual monoculture.
A perfect term for it. Research investment has favored incremental improvements on easy-to-monetize, statistically backward approaches, rather than funding the harder foundational research into neurosymbolic or post-AI quantum systems that promise true long-term breakthroughs. This monoculture has slowed the true technological progress toward AGI relative to what is scientifically possible.
Which brings us back to the core concept. The financial rewards have been chasing backward AI, which only predicts a past it has already seen, while the future really needs us to engineer solutions using forward AI.
That is the essential transition. If current generative AI is backward AI, a system fundamentally constrained by predicting a bygone past using historical data, then sustained ROI and technological progress absolutely rely on pivoting to forward AI. These are systems that actively help us create and assure the future. And this is the domain pioneered by Dr.Eng-Prof Yogesh Malhotra's 3 decades of post-AI quantum R&D, which bridges that gap between today's technical limitations and tomorrow's necessary outcomes.
This framework, which began pioneering at the dawn of the World Wide Web, is founded on a completely different philosophical core than mainstream AI. It's centered not on prediction, but on the proactive anticipation of surprise.
And that concept is the inverse of traditional deterministic risk management. Standard AI and financial models operate on the premise of predicting the historical past. They assume that if you have enough data, the future will statistically resemble the past.
But that's not how the real world works.
Not at all. We live in what are called wicked environments, worlds characterized by rapid, complex, and chaotic change, where the future simply does not resemble the past.
So relying on backward AI in a wicked environment is, what, like trying to navigate a new city using only your car's rearview mirror?
Exactly. The rearview mirror only shows you where you've been, which is useless for navigating an unprecedented dynamic change. The fundamental goal of the post-AI quantum R&D framework is to advance beyond mere prediction to engineer systems that assure outcomes and, crucially, transform uncertainty, which is typically viewed as a threat, into a strategic advantage for maximizing ROI. This requires a philosophical shift in how we approach intelligence and risk.
This framework also requires a major reevaluation of the role of the human, which has often been marginalized in the narrative of AI supremacy, where AGI is supposed to replicate or replace human intelligence.
It fundamentally challenges the mainstream, often financially driven premise that AI is human-like. Dr. Malhotra's work argues that AI is not human-like. It's a mechanistic, deterministic model that operates based on algorithms and predefined rules, even probabilistic ones.
And what these mechanistic AI models fundamentally lack are the critical derivatives of the human system. Things like
imagination, intuition, insight, creativity, and ingenuity.
These unique human capabilities are referred to in this framework as the human quantum mind.
That's right. The concept of the human quantum mind emphasizes these capabilities that are required to manage dynamic, adversarial, and quantum uncertainty and complexity. These are the qualities that allow us to generate novel, non-deterministic solutions, to see and create shifts in trends far beyond the sensing or pattern recognition capabilities of current AI systems.
Can we put that in context? How does human ingenuity fundamentally differ from statistical AI?
Well, consider any major historical invention, the wheel, the discovery of penicillin, or the integrated circuit. These were products of human imagination, intuition, and hypothesis testing. They did not exist before they were created.
Right. There was no training data for a wheel before the first wheel?
Precisely. If human civilization had been waiting for statistical AI to advance us, there would have been no historical data or pictures of a wheel or fire before they were invented. These products of civilization are functions of human ingenuity, something deterministic AI cannot replicate because it is restricted by the bounds of its training data.
And this distinction is so foundational that Dr. Malhotra's work has leveraged neuroscience, specifically from Antonio Damasio, to produce what's described as the first known software engineering blueprint for quantum consciousness.
It's a profound claim, moving toward engineering consciousness in a technical blueprint. And this distinction also changes the nature of programming itself, countering that fear that AI will just replace developers.
A fear we hear a lot about.
We do. The vision aligns strongly with observations by industry leaders like Bill Gates. AI won't replace programmers, not even in a century. This is because programming is evolving beyond the keystroke level and simple automation. The focus is shifting to deep thinking, to solving hard, novel problems, and to imagination, the very definition of the human quantum mind. Coding is now about the architecture of solutions and human ingenuity, areas where no algorithm, however scaled or sophisticated, can match human capability in generating non-deterministic breakthroughs.
So, if the technical limitations of generative AI or backward AI are clear and human ingenuity, the quantum mind, is the necessary core, what is the architectural blueprint for this forward AI that can assure outcomes?
The technical solution proposed is the development of quantum-augmented self-adaptive networks, or QCASNs. These post-AI quantum networks are specifically designed to manage unprecedented uncertainty and complexity by fundamentally shifting AI operations, or AI ops, from relying on the historical past to being driven by future-oriented augmented quantum AI. They aim to deliver superior ROI success precisely because they are engineered to deal with surprise.
Okay, let's break down the three powerful core elements embedded in the QASN's design. These are what differentiate it from a standard LLM architecture. Let's start with the concept of augmentation over automation.
Augmentation over automation is critical. While automation is excellent for internal efficiency and optimizing known processes, its benefits in terms of investment returns are fundamentally limited. More importantly, the most critical risks and surprises encountered in wicked environments simply cannot be managed by automation alone. Automation fails when the scenario is unprecedented.
Whereas augmentation.
Augmentation is required because it involves the emulation of human intuition and sense-making, or what we call quantum minds, in the system. This means integrating human-machine, quantum computing, and AI in a hybrid approach. This strategic leveraging of human capabilities is what leads to greater investment benefits because it allows for agile, intuitive management of previously unseen threats, enabling an assurance of outcomes that automation just can't provide.
The second element focuses on achieving system-wide resilience through adaptation.
That is the self-adaptive focus. This architectural principle builds on decades of R&D in self-adaptive complex systems and chaos engineering. The primary goal is to achieve levels of agility and resilience that extend far beyond traditional silo-focused knowledge management systems. It's about network-centric management of dynamic change, quantum uncertainty, and complexity. It's about building sustainability and agility into the core system, rather than trying to retrofit solutions after a crisis hits.
And the final element is essential for addressing the ethical and bias flaws of generative AI, which are inherent because of their reliance on historical data.
Exactly. The third element is meaning-aware, human-centered design. We know generative AI is inherently biased because it learns the biases present in its historical training data. To overcome this, the design must incorporate human context and values. This is essential for building robust ethical frameworks. By focusing on human meaning, context, and the assurance of desired outcomes, we transition from measuring success based on how much data is processed, which is the current metric, to measuring how robustly and competitively outcomes are achieved in alignment with human values.
So this shifts the entire metric of success for the future of AI. It moves away from input metrics, how many chips or how much data, to verifiable output performance.
The framework fundamentally establishes that inputs do not matter, outcomes matter. The measure of success for forward AI is focused entirely on maximizing ROI in a genuinely competitive and innovative sense. As Dr. Malhotra puts it, the lesser dollars you spend to make more dollars, the smarter you are.
I like that.
It emphasizes creativity, ingenuity, and efficiency in achieving superior performance outcomes at a lower cost. It positions the human quantum mind as the irreplaceable engine of superior results. This transition from backward AI to forward AI represents one of the most significant paradigm shifts in artificial intelligence since the advent of computing itself.
This discussion reveals a tremendous fundamental tension. The market, driven by Goldman Sachs' macro-optimism, is betting trillions on the success of backward AI to deliver the results required for forward AI returns. We must now look closely at the specific financial risks and opportunities associated with this technological disconnect.
The core financial question, as we established, is whether the return on AI investments will justify the projected multi-trillion-dollar capex. When you have NVIDIA's CEO projecting $3 to $4 trillion in AI infrastructure spend by 2030 alone, the market requires not just profits, but massive transformative profits to justify that level of commitment.
Let's start by detailing the optimistic view, the argument that the spending is, in fact, justified and sustainable.
The optimistic view, often championed by analysts like Joseph Briggs, holds that the long-term economic gains will ultimately justify the spending. Briggs estimates that generative AI could create a staggering $20 trillion in present discounted value of economic value in the U.S.,
20
with
trillion.
approximately $8 trillion of that flowing back to U.S. companies as capital revenues.
Okay, 8 trillion in capital revenues should easily cover the 3 to 4 trillion in capex. What is the fundamental rationale supporting this optimism?
The investment is considered sustainable for two main reasons. First, companies are aggressively pursuing first-mover advantage, believing that whoever wins the AGI race will capture exponential future profits that will dwarf current spending. Second, they view the investment in capacity chips, data centers, power generation as a necessary foundational step. They use the analogy of the fiber optic network build-out in the 1990s.
Right, but that internet infrastructure boom also ended in a bust. So what's the positive takeaway from that parallel?
Well, while that period saw a painful burst of the bubble, the massive necessary capacity was laid down. That capacity, the fiber networks, the data centers, enabled the modern internet, mobile computing, and cloud services to flourish years later, ultimately leaving everyone far better off. The optimistic view is that today's AI capex is laying the crucial foundation for the AGI future, and despite short-term bubbles, the long-term macro backdrop remains solid enough to support the spending.
But the skeptical view, held by Kahn and Marcus, argues that this is still a bubble because the necessary revenue streams haven't materialized. It creates that circular ecosystem where money flows to the infrastructure providers, not from the customers.
Exactly. The skepticism hinges on the sheer scale of investment versus the current customer revenue. Kahn's analysis suggests that the power needs alone for the forecasted data centers imply an eventual investment of $4 to $10 trillion.
So you need an $8 to $20 trillion revenue stream just to pay it back.
That's right. And the current revenue streams, primarily coming from niche developer tools or highly subsidized cloud services, are dwarfed by the infrastructure spending. This creates the circularity where the valuation is almost entirely hinged on hope for massive, non-deterministic breakthroughs, the achievement of forward AI capabilities. Before 2030, profitability becomes a make-or-break requirement. If the technical shift to forward AI fails to materialize, the investment becomes unsustainable.
So investors are navigating this tension between justifiable long-term capacity building and the immediate lack of revenue realization. Where does Goldman Sachs see the immediate lower-risk investment opportunities across this turbulent landscape?
They view the opportunities in three main layers, which correspond to the current build phase of the AI revolution.
Let's start with what seems like the safest bet, the picks and shovels.
The picks and shovels layer includes the foundational infrastructure providers, semiconductor companies like NVIDIA, the cloud computing hyperscalers, and infrastructure builders like data center companies and power suppliers. These firms are inherently positioned to capture gains because the immense mandated capex has to flow through them first. They are the initial, relatively safer beneficiaries of the build-out, benefiting from a guaranteed demand spike driven by the AI arms race.
And second, there's the application layer, which seems to carry higher risk but also potential for exponential reward if they succeed in engineering outcomes.
That's the application layer. While many investors currently exhibit uncertainty here, believing all the value is captured by the massive foundational model providers, Goldman Sachs sees a huge opportunity for startups and incumbents that can leverage the new capabilities reliably. This spans vertical domains that require complex integration, like observability, cybersecurity, advanced data analytics, legal services, and CRM. This layer requires the creativity and work of getting non-deterministic models to work reliably in specific mission-critical production use cases.
So this is effectively where backward AI is engineered to deliver forward AI outcomes.
That's the perfect way to put it.
And finally, opportunities exist beyond just the massive hyperscalers in the small and mid-cap space.
Yes, the third layer is small and mid-caps. Opportunities exist here for firms acting as enablers or specialized picks and shovels of the AI boom, particularly in the U.S. and internationally. These companies often benefit from anticipated rate cuts and accelerating earnings as AI adoption broadens, but this area requires careful active selection and due diligence due to higher market inefficiencies, thinner balance sheets, and idiosyncratic risks.
This high-stakes investment environment, fraught with technical limitations and financial concentration, underscores the final and most critical point, the necessity for advanced risk management that goes far beyond current models. And this brings us directly back to the principles of forward AI engineering we just discussed.
This is perhaps the most urgent implication of the post-AI quantum work. The R&D by Dr-Eng-Prof Yogesh Malhotra addresses critical risk areas that traditional financial models are simply incapable of handling. One specific and dramatic warning cited in the source material is about the approaching global cyber insurance crisis.
A crisis that could dwarf the global financial crisis. That is an extreme claim. How is that crisis being structured financially?
It stems from the widespread misapplication of value at risk, or VAR, a model derived from quantitative finance to cyber risk insurance underwriting.
In VARs.
It's a statistical model used to estimate the maximum expected loss over a specific time horizon. The problem is that VAR relies on historical data and assumes losses follow a normal, predictable distribution. This means it fails spectacularly to account for tail risks, unlikely but massive systemic losses.
So VAR works for predictable market fluctuations, but not for catastrophic correlated events.
Exactly. Cyber risks are fundamentally characterized by tail risks and systemic correlation. One major successful cyber attack can quickly spread across the entire insured pool, creating correlated losses that exceed the statistical properties of VAR. The source warns that this commercial reliance on flawed, backward-looking quantitative models will, unless immediately corrected by new engineering, lead to a worldwide economic shock comparable to, or potentially exceeding, the global financial crisis.
So this highlights the absolute necessity for quantum uncertainty management, the engineering of outcomes in finance and systems design.
Precisely. The core R&D focuses on managing dynamic uncertainty and Nician uncertainty, the unknown unknowns. This goes far beyond standard model risk management, which only deals with node distributions. Managing adversarial uncertainty and time-space complexity is necessary for creating resilient and sustainable systems across defense, finance, and technology. This focus on preemptive and anticipatory risk management, the anticipation of surprise, is the essential counterpoint to the massive, risky CapEx. It ensures that the trillions spent on AI build resilient, future-proof systems, not fragile ones destined for a wily coyote collapse.
This has been an incredibly rigorous journey through the future of AI. We started by contextualizing Goldman Sachs' robust financial optimism, driven by the prospect of historic productivity boosts that justify trillions in capex, while simultaneously recognizing the historical risk of an innovation-driven bubble forming due to high concentration and, well, a reliance on hope.
We then identified the deep technical limitations of the current technology, confirming Gary Marcus's critique that generative AI is autocomplete on steroids. It's inherently constrained by statistical analysis and suffering from an intellectual monoculture. The failure of scaling laws really signals the technical limits of backward AI's dominance.
And finally, we explored the necessary architectural shift proposed by post-AI quantum R&D, the transition to forward AI, driven by the human quantum mind and the technical blueprint of QSNs. This shift focuses on augmentation over automation, self-adaptive resilience, and meaning-aware design, fundamentally changing the goal from mere statistical prediction to the proactive anticipation and engineering of desirable, sustainable outcomes.
The central lesson for you, the investor or the engineer, is clear. In a world increasingly defined by wicked environments and the anticipation of surprise, maximizing returns and mitigating systemic risk is fundamentally an engineering challenge, not just a data challenge. The future of enduring value lies in actively engineering paradigm shifts, specifically those that augment human capability and assure outcomes, rather than passively waiting for the current technology cycle to collapse or achieve unexpected breakthroughs using flawed statistical models.
And that leads us to our final provocative thought for you to consider. The current AI race is focused entirely on optimizing training queries and computational power. It's a race for statistical consensus based on historical data. If the goal is truly AGI and enduring value, we must embed creativity and conflict into our systems. Philosophers distinguish between types of thinking. If current LLMs are built for Lockean or Leibnizian thinking consensus based on shared facts, how can we embed the necessary conflict-driven creativity, the Hegelian synthesis, into our AI architectures to truly solve the world's most wicked problems?
That's a fascinating question.
Hegelian synthesis requires the collision of conflicting ideas, a thesis and an antithesis, to create a breakthrough synthesis. The next generation of intelligence might depend on engineering machines that actively seek intellectual conflict, not just agreement.
Thank you for joining us for the deep dive. We hope this analysis helps you navigate the uncertain but incredibly opportunity-rich terrain ahead.